Begin again. Thank you for joining this webinar. We're going to talk about how occupancy data can be a useful metric to help drive improvements in energy efficiency in buildings. And just before we start, I want to say that this webinar is being recorded. We'll put it online so you can refer to it at a later time. And also there is a chance for you to ask questions using the chat feature, which I believe is on your screen. You can enter your questions and we'll address those at the end of the seminar. So hello again. So I'm Philippe with Terabee. I'm joined by Dominik, who's our head of sales. And Terabee, we're the hardware side of this use case that we're going to be discussing. And we're joined by our partners, Feedback Solutions. And I guess you could say Feedback is more the software side. And with Feedback, we have Chandan Chowdhury, who's the CTO, and David Whalley, the CEO. And Feedback Solutions is using data from occupancy sensors to manage ventilation systems in buildings more efficiently. This helps drive energy savings, cost savings, and also helps reduce the mechanical wear of these ventilation systems, which are generally quite expensive. So what we're going to talk about are basically four main things. First of all, we'll give an overview of our rationale, why we believe occupancy data is an important metric to not only measure building performance, but also help drive improvements in building performance, both from an energy perspective, but with other use cases as well. We'll have an overview of our people counting solutions from Terabee. And then our friends from Feedback will give some examples of how they've used the data from occupancy sensors to manage ventilation systems, and they'll explain some of the use cases that they've deployed with their customer base. And then we'll finish with a few questions, and we'll do our best to answer the questions. Feel free to add them as we go along, and we'll get to those at the end of the session. So who's Terabee in a nutshell? We're a French company. We specialize in optical time-of-flight sensing technology and thermal sensing technology. Those technologies are incorporated into our people counting sensors, and the data from those sensors is used by our partners, such as Feedback Solutions, to drive the use cases that we'll be talking about today. So we partner with a number of different companies, a lot of integrator companies. Feedback Solutions is of course, a prime example. We also work with different solution providers or distribution companies, and of course, we're happy to add more partners as we continue to grow. But let's get right down to it. Why should we use occupancy data? Why is this an important metric? And often a neglected metric, but gaining in importance. We see that there's a number of approaches today being used for measuring and managing energy efficiency. One of which is surface area. So we can, let's say, target ventilation or energy efficiency performance according to specific surface area of a building spaces. But this has some drawbacks because it doesn't really capture how that space is actually being utilized. So for example, if you have a given space, let's take an office space as an example, you can set up some targets for airflow, the volume of airflow in liters per second according to a specific surface area, or the energy consumption for that specific surface area. And as you achieve those metrics, you may think you're doing a good job in terms of managing the energy performance of a building. But in reality, those metrics can be quite different depending on how that space is being utilized. So a space that's only at 50% utilization is probably not as efficient as a space that has a lot more occupants and has higher utilization. And by utilization, I mean how many people are actually there using the space. And we see this in some of the research that's coming out. For example, last year in a research publication around building design, one of the authors really focused on the need to look at both space efficiency and energy performance together. And really the only way you can do that is by having real-time accurate occupancy data. And then other initiatives, for example, there's in New York City, the Benchmark 8760 initiative is pushing to include timely occupancy data as part of any metric to monitor building energy performance. So we see this as a kind of a growing need and a growing awareness in the industry. Another approach that's often used to monitor and manage energy performance in buildings uses air quality, in particular for ventilation of buildings. But indoor air quality has a drawback in that it is a lagging metric, meaning that it is after the fact. So this really only enables a kind of a reactive energy strategy as opposed to a proactive one. So to illustrate this, if we take a space, a building space or an office space, and we don't know the occupancy, well, over time, we can expect that the air quality will start to degrade with the presence of people, and an occupancy sensor, or excuse me, an air quality sensor can detect that and then engage in a ventilation approach that brings the air quality back to the desired levels. On the other hand, if you have a known occupancy of a space, this allows you to initiate immediately the appropriate ventilation and maintain the air quality at the appropriate comfort levels. And in this case, your air quality sensor is actually helping you to validate that your ventilation strategy is working. It's more just a check, let's say. And this has a number of benefits. So if you maintain the air quality at the right levels for your occupants, this means better comfort. It should also lead, therefore, to better productivity. And of course, you're using your ventilation system in a more optimal manner. So I just want to summarize this overall rationale. What are the overall benefits of having this occupancy data? First of all, one is that occupancy is a leading indicator. That means it's ahead of the game, and this allows you, because it's a predictor of what your building needs in terms of HVAC, it allows you to implement a proactive energy strategy, whether it's for ventilation or for heating. The other advantage is that occupancy is a reliable and accurate metric compared to other metrics that might be used. So, for example, it's certainly more accurate than might be CO2. CO2 sensors have a lot of variability in their detection, require calibration and things like that. And also, if you're using surface area as a benchmark for different energy metrics, this doesn't address the ebb and flow of occupancy that happens in real time. So you're basically basing it on historical averages. And this leads to the advantage that by having the real-time data, you can remove the effects of variability or unpredictability in building occupation. So, for example, if you have unforeseen events like a transportation strike, for example, or extreme weather events, or any other event that might affect how many people show up on any given day to your building, if you don't have the real-time occupancy data, there's no way that you can automate how your building management system can react to that variability. And then the final benefit is that occupancy allows for more use cases than you might otherwise be able to have. So we've talked about energy management, ventilation, and the savings that might be associated, and feedback will go into more detail with concrete examples. But also you can use occupancy data to see how the space is being utilized, whether the real estate assets are being optimized, whether certain facility management services like cleaning or maintenance are being managed in a more timely way as occupancy ebbs and flows. So there you can gain also some savings. So those are all the different benefits that having the real-time data of occupancy can provide. So what do we mean by occupancy and people counting? I'll pass it over now to Dominik, who can give a more precise example of our different solutions.
Thanks, Philippe. So now we all know what are the benefits of the real-time data, not the lagging one. But I would like also to tell you how we can collect such data with our sensors. So basically at Terabee, we have two types of sensors, the people flow counting and people occupancy sensors. And they all share our biggest USPs across the whole product line. So first of all, as Philippe mentioned, we are the time of flight company. So it means that we do not use any RGB cameras. Our devices cannot capture the identity of any people. We are using either the time of flight or the thermal. So basically, this is fully GDPR by design, means that there is like no privacy issue on your side when you are installing the devices. But still, with this technology, we can deliver, and we are delivering the highest accuracy on the market. 98% or higher. And what is also very important for our customers, for the companies that work with our devices, we are fully like platform agnostic. So you can buy the device and collect it via the LoRaWAN or PoE. You can use your own cloud system, and we can push data from the sensors using the MQTT or HTTP pushers. You can ask each of the sensors via the API. So basically, it does not matter what is your the full infrastructure. And on top of this, we are not pushing our customers to SaaS systems. So you can buy only the hardware, resell the hardware, and sell the whole package to your customers with your own IoT platform, with your own data analysis platform, whatever the product that you have. Next, very important thing that's common to all of those sensors is the fact that they are super easy to be installed. Especially the PoE ones, which is one cable and that's it. They are already online. They can push data from just from after the installation. They do also compute data directly on the device. So the sensor basically pushes data, which is like ID of the sensor, timestamp, in and out data. Nothing more, nothing less. So you don't need any local server that we collect large amount of data and analyze it. It's very simple to be used. Next slide. So people flow counting, and those are the devices that need to be installed above the entrance. Yeah. So when people are passing by through the entrance, we have two types of the devices that basically are designated to the different types of the entrances. One, people flow counting M, which is a smaller one, is designated for the doors up to 1 meter wide. It's for single door, one person at a time. And then we have a people flow counting LXL, which can cover from 1.5 meter wide doors up to 15.4 when you collect multiple devices into one. So we are also able to cover the area like on, I don't know, like in malls or wide open areas when you need to cover large entrance, basically doorless entrance that is up to 15 meter wide. Still, this will be uploaded to your IoT server as the one device. So you will see like entrance, again, only ID, how many people came in through in or out data. This is all that you get. And those devices are using either LoRa or PoE. Next slide. And the second type of the devices that we have in our offering are the people occupancy. Mounting is a little bit different. You need to find like the center of your space that we would like to monitor, but it can cover a very wide area, up to 64 square meters or 700 square feet. So this is a large zone that can be even divided into multiple regions of interest, up to 8 of them. And we can send data to the server basically for each of the zones separately. Still, this one is using the thermal sensor, but still delivers the 98% accuracy. Again, it's fully GDPR compliant because it's a thermal signature of the human body. You cannot see anything. There is like no privacy issues at all. It gives you real-time monitoring. We are still using the PoE or LoRa, MQTT, HTTPS. So basically, all of the things that are like common for all of our people flow or people occupancy counting devices. Next slide. And so as we know now how the importance of the real-time data is and which sensors you can use from our offering, we can now move on to the real-life scenario from Feedback Solutions company. And we go here for the presentation from the Feedback Solutions.
Thank you, Dominik. Appreciate that. So Dominik and Philippe have teed it up perfectly for us. So with a partner such as Terabee, our reason for being for Feedback Solutions is using the occupancy intelligence to reduce greenhouse gas emissions, also being cognizant and taking care of or optimizing indoor air quality. So it's possible we stole this phrase from a very ubiquitous advertising campaign that people would recognize in North America, only pay for what you need. So to Philippe's point, that the current state of the art in the built environment in many cases is using proxies at best for what the actual occupant count is in a building. So it's still a blind spot. It's still a very, very important missing ingredient in terms of what the building operators and managers are able to achieve in terms of optimizing the heating, ventilation, air conditioning systems. So our platform, to Dominik's point and Philippe's point, it's a software platform. So we're taking the raw data from the Terabee sensors. The secret sauce that Feedback has developed is the ability to take that raw data and turn that into a zoned occupant count in real time. What this means is that the building operators can then optimize the building management system, reduce fan speeds, reduce the amount of outside air that's heated or cooled based on a real-time occupant count. So you're not overdoing it, and you're not underdoing it. And this is via BACnet, so that this is a protocol that the building operators understand, so it's easily ingestible. That's part of the key failings of the solutions, the attempts today, if you will, in the built environment, is the ability to get this occupant, zoned occupant data ingested by the building management system in a manner that it's actually minimizing programming requirements, and it makes it a seamless integration with, as you can see, all of the major building management systems, controls providers, if you will. So this is something where you're working with the incumbent controls vendor, you're not competing with them, you're giving them a more granular data set to optimize the HVAC. So sample integration, just to give you in the weeds a little bit for the integrators in terms of where the software piece fits in. So you've got the people counting sensors. Typically with our customers, they do want the PoE connection. So it's a PoE to the customer's switch. And then the data is being transmitted to our edge device, which is making the calculations and then sending zoned occupant data to the building management system. Once that programming exercise is done once, the savings happen seamlessly in the background. And typically, and we'll give you the case study with NYU, the customers are still looking for that data set in terms of how their building's being utilized. To Philippe's point, there's other stakeholders, faculty, security, et cetera, that want to understand how these spaces are being utilized on an ongoing basis. At the same time, if there's an indoor air quality monitoring desire, that also too can be brought into both a monitoring function and also through the edge device, one edge device per building. We can also incorporate that into the sequence of operations, have an automatic ventilation response if there's an alert on the indoor air quality side. At the same time, for the integrators, we can have a third-party integration as well. The use cases for us, the verticals that are most popular for us, commercial office, the public sector, that's growing very, very quickly. And Philippe alluded to the mandates, particularly in the Northeast United States and California, very stringent mandates to reduce GHG emissions. Higher education is very, very active right now, and retail is also a very good use case that we're expanding with as well. We'll focus on the higher education use case. So this is the School of Dentistry. This is New York University, NYU, their Washington Square campus in New York City. So the test here, this was essentially the state of New York in conjunction with the Department of Energy saying, okay, Feedback Solutions, with this software solution you have, occupant-based demand control ventilation, compare this to a legacy system, which was, in this case, a CO2-based demand control ventilation platform. So we isolated the equipment, isolated a specific area, three floors within that building, to then test the efficacy of this solution. You can see this is a fairly modern building, very, very high end. So it's getting right down to the building level and more granular down to the lecture halls, and I'll explain what that means in terms of energy savings opportunities. So those are the three floors that were isolated, one single air handling unit. So that became the reference point. So getting right down to the granularity of a lecture hall. So these are in many cases 200, 400 student lecture halls. So you can imagine the variability in occupancy from 0 to 300 to 400 throughout any given day. It's a huge opportunity to modulate the HVAC systems. So here with NYU, this is their actually a screenshot from their building management systems. This is what the energy team would see. So we're tracking occupancy. That's now being displayed on their building management system. Still tracking CO2. What will happen, being proactive with ventilation, those CO2 spikes will be much smaller and flatter. So you will not have issues with the CO2 rising too much. And within that lecture hall, what we're able to do with the granularity of the occupant data is to modulate the amount of outdoor air that's being heated or cooled and ventilated into that space. What that then drives at the air handling unit level, that's the larger equipment, the larger fans, tremendous amount of fan energy savings. And this happens automatically. This happens in the background as those occupant levels in those lecture halls go up and down. So and at the same time, again, the data set that the faculty and energy team want, this is very, very important to them. They now have 16 buildings, I think, on one dashboard. They can toggle from building to building and see exactly what's happening in real time and see what the historical patterns have been with the usage of those facilities. And so the energy savings, again, this is what the energy managers are looking for. To give you some metrics here, the electric savings, 17.22 kilowatt hours per meter squared per year. That's very, very significant. So what that meant for NYU, that the energy consumption related to the HVAC system reduced the greenhouse emissions by 18%. That's very, very significant, particularly in a market like New York, where they have specific mandates, penalties if they do not reduce their GHG emissions. And then this is very, very generalized, but if we're seeing in France and Germany anywhere from 23 euros per kilowatt hour to 33 per kilowatt hour, those payback periods are going to be very, very compelling, particularly in markets where there's incentives available from utility companies. So this drove a rollout I mentioned to another. Now we're working on our 17th building, and this is a perfect story in market. Start with one building, and the land and expand opportunity is there once the energy team sees the effectiveness of the technology. And then in terms of a pilot, in terms of a demonstration site, any space with variable occupancy, full floor office space, large lecture halls are very, very easy. They need a dedicated HVAC system, and air handling units or VAV boxes, we call them, variable air volume boxes. Fan horsepower 20 plus is ideal. Variable speed fans installed. That's ideal. Any building that touts itself as LEED certified or is at a tier 1 university site is likely going to have all of these ingredients already in place. And of course, very importantly, there's a BMS that supports BACnet. Again, any modern building that's going to already be in place. And the stakeholders, this is very important. Oftentimes it's a sustainability team, or it's that there's a specific role, a department that's responsible for the energy management, energy consumption for that campus. That's typically the entry point for us and the building owners themselves. And so obvious partnership opportunities with Terabee's integration partners, energy savings, particularly if you've already got sensor infrastructure in place. That is an ideal use case for your customers. They can turn what's already been invested into an energy savings play. And then what that'll hopefully do is mean that they want to install sensors in more buildings because you're getting an actual quantifiable return on investment. And so we see that as a ideal use case. Test it where the sensor infrastructure is already in place, and then that'll lead to more customer opportunities because you're going to see a really good return on that investment. So I'll stop there and hand it back to the Terabee team.
Yeah, we had a question that maybe would interest our audience. Is if I can just see the question. I think it was basically like as you implement these energy saving strategies, who are the people that you're dealing with in the customer side? Who are the influencers, and who do you need to convince basically to take on a solution like yours?
That's the best question in terms of enterprise sale. It's typically in our market. There's oftentimes a team that they'll call energy management. So sustainability may or may not be in the weeds in terms of managing the energy consumption with the campus buildings, it's oftentimes a good place to start. So sustainability, energy management in a campus setting, and you're going to have building operations involved and the BMS provider. So the perfect situation is where you've got NYU, for instance, very, very engaged energy management team. I mean, NYU has an operating budget of over $17 billion a year. So they spend a ton of money. They're one of the biggest landlords in New York City. So their energy bills are, as you can imagine, quite substantial, and they're also in a very, very expensive market power-wise with a dirty grid. So that's the perfect storm for a group like ours trying to reduce GHG emissions and reduce the spend. So with them, it's really energy management team, and with them, they've got a very engaged building management system operator with automated logic, which is a subsidiary of Carrier. Those are the two ingredients that help the speed of deployment.
Okay, thanks. We do have a few other questions I see on the chat. So can we use these sensors in a sauna, 60-degree temperature?
No, unfortunately, no, you cannot. But basically, the solution is just to install it on the outside when people are coming in. So on every entrance, you can cover it, and then everything should be fine. The time-of-flight technology also means that you don't need the good lighting conditions. It can be totally dark. So just the placements of the sensor outside, and you should be fine.
Yeah. And then we have a question from Louis. Is there a maximum height to install this type of sensor? He has some use cases with more than 10 meters height ceilings. And yes, there is a maximum height that's in the data sheet. So it depends on the sensor. Generally 4 meters for our sensors is the maximum. And in this case, you would need some kind of a way to install the sensor at that height. So we have customers that use either poles to bring the sensor down to the right level, or other apparatus to bring the sensor out from the wall. It really depends on the architecture of the space.
Yeah, we've done the same thing in some of our installations, either a pendant from the ceiling, or to your point, if it's over the entrance, a bracket over the entrance, which is oftentimes far better than trying to deal with a 20-meter height.
Exactly. Then there's a question about, can we use the system or the sensor without a BMS? Well, I mean, I can answer that. Yes, you can use it without a BMS if you don't want to control the BMS. So if you just want occupancy data for analytical purposes and learning about your utilization of spaces, that's fine. It's not required to connect it to a BMS, or to connect with the controllers of a BMS. I think David and Chandan, that's where you guys come in, is that you are able to make that interface with the BMS, and then drive the response from the BMS and the HVAC system.
Yeah,
So,
in some cases there will not be a building management system in place. So in some retail big box environments, there will not be a building management system, but we can still use the data, the occupancy data, to control the rooftop units with a DDC controller. And oftentimes those are a wireless controller. So most of the big HVAC OEMs have controllers that we can add to the rooftop units, because oftentimes they're going to be constant volume. So that's low-hanging fruit in terms of energy savings. If you can use the real-time occupant data to control those rooftop units with or without a BMS, there's a really good opportunity for energy savings.
That's true. And some of our sensors do have a 0 to 10 volt analog output, which can be used to control locally a heating or ventilation system without having to wire to some central unit. So that's true.
Yeah.
Okay. A few more questions and then we'll be out of time. Another question is, any limitation for relative humidity values? Yes, Tarzi, are you in Japan by any chance? Because we're working on a case with a customer there that they want to use it in fitness centers, and there's a lot of saunas in these fitness centers as well. Yes, there are some humidity limitations. I'd have to check on the details, but you can check on the data sheet as well for the sensors. Again, it depends how well ventilated as well the sensor is. The risk might be condensation on the lens, which would impede the performance of the sensor. That's kind of the thing to worry about.
Yeah.
Another question from Karen: what other building types would be appropriate other than higher ed? Higher ed is a good use case because of the campus nature of the infrastructure, but basically any type of office building or commercial real estate building is good. Yeah, there's really no limitation, I would say. It really depends on what the end customer needs, and we can assess if the solution is appropriate.
Office is really important. I mean, a lot of the large commercial real estate facilities management firms are looking to deploy these types of solutions, both from a space utilization standpoint, the data on the utilization of the assets, and more they want that data to be also utilized for other stakeholders, both the energy teams, reducing greenhouse gas emissions, reducing OpEx, real-time responses from security, cleaning, etc. So those use cases are very real, and the big facilities management firms are really hungry for those solutions. That's going to be a big next 2-3 years. That's going to be a huge driver in the market for all of us.
Yeah, that's true. I see another question here. Solutions seem to be targeting office, but have industrial facilities been considered? I have buildings with heat sources moving in the area, not human things, machines. Will the system be confused? Or are they able to make the difference between human and machine shapes? Well, in general, yes. The people counting LXL algorithm is designed to identify a human form and count it. So you normally would not have occupancy driven by non-human shapes. So that should be okay. It really depends on exactly what is the shape and form of these moving machine heat sources that you mentioned in your question.
There a question. So
did I miss a question?
Yeah.
Okay.
Yeah, there is another question for feedback solution. Can the Intel NUC be virtualized?
Can the
Can the NUC?
Can you repeat that question, please?
Yeah, can basically your Intel NUC, can it be virtualized somehow?
Virtualized?
Virtualized using a VLAN. Typically, we prefer to send an Intel NUC to the site because it's pre-configured with all with the solution and the sensors. Plus, it has a lot of alerts which are built in, so we prefer to use that.
Okay, then we have a question from Thomas Collins. Are we looking for channel partners to find new projects or independently selling hardware, software? I think we're looking for channel partners for sure. So open to discussion. Please contact either Terabee or Feedback Solutions if you want to discuss further. We're happy to discuss any opportunities, and we can see if we're the right partner for you or not. Yeah, or if Feedback is the right partner as well.
Well said.
Okay, well, I think we've passed the time, so maybe we can wrap it up. So I want to thank our friends from Feedback for joining us, and we hope you've enjoyed the presentation. Like I said, this will be put online, so all of those who have signed up for the webinar will obviously get a link, so you can review the presentation and the webinar at a later date. And thank you. You'll also have, as you can see, the links and email contact to get in touch with people from either Terabee or Feedback Solutions as needed. Thank you very much for your time, and hopefully we'll be in touch for further adventures.
Thanks to the Terabee team. You guys are great to work with. Take care.
Thanks.
Thank you.
Bye.
With you.